Hello, this is James. I do marketing at Stedi, and today I'm going to give you a demo of Stedi's insurance verification integration for Amazon Connect Health. Amazon Connect Health is a managed AI product. It lets you create AI agents that help with common healthcare related tasks. What we're going to focus on today are patient engagement agents. These are essentially voice AI agents that can take phone calls from the patient to the provider. For example, if you're a patient calling maybe your doctor's office and you want to schedule an appointment, the agent can answer the call, verify that the patient is who they say they are based on the provider's records, and then help the patient schedule an appointment. Patient engagement agents also have the option of hooking up to an insurance verification integration. So if you've ever been to a doctor or a dentist and they've asked for your insurance card or collected your insurance information and then told you whether your visit was covered by insurance or if you owed a copay, what likely happened behind the scenes was a real-time eligibility check. Real-time eligibility checks are standard healthcare transactions. They return information about a patient's insurance coverage and benefits. A patient engagement agent can use an insurance verification integration to verify a patient's insurance coverage while they're live on the phone and also return things like a copay. What I'm going to show you today is an integration that connects Stedi's real-time eligibility check API to Amazon Connect Health through a patient engagement agent. To help developers build these insurance verification integrations, Amazon has provided a sample reference implementation that's vendor neutral. What I've done is take a fork of this reference implementation and then customize it to use Stedi's API. You can see my reference implementation here. I'll walk you through the broad flow. The integration is essentially an AWS Lambda function. Lambda functions are serverless functions that live on the AWS cloud. So what happens is when a patient engagement agent is on the phone with a patient, it can collect information from the patient, such as the patient's name, member ID, date of birth. It can then pass that information through a request to the AWS Lambda function that we're going to build here. The Lambda function then maps the data that the AI agent has collected to an API request for Stedi. It then makes the API request, gets back a response that contains the patient's insurance coverage and benefits information. It then maps that data back to a format that the AI agent can understand. And then the AI agent responds to the caller to provide insurance coverage information and benefits. None of this is visible or surfaced to the user. From the patient's point of view, they're just talking to the agent. They never know that Stedi is involved in the process or that even a real-time eligibility check is happening. I'll give you a really quick tour of the code base. Most of the action happens within this functions directory or function directory and is done by this handler. Essentially, the handler takes the request as described earlier. It then maps the request to a vendor's API schema. It then makes the API request. It receives the response, maps it back, and then it returns a format, which we'll see later, where it provides a status code to let you know if the request went through and everything worked. And then a body that contains insurance coverage information, coverage dates, and a copay. And I'll show you how all of that works later through a live demo. The reference implementation I've put together also includes a SAM template, which allows you to build the Lambda function locally and then deploy it to AWS's cloud. This template includes everything you need in order to use the Lambda function. It includes a secret manager for your Stedi API key, as well as everything else that the function needs to work. You don't need to understand this template in order to use it. I'll demo how it works shortly. The one thing you will need before you build and deploy the Lambda function is an API key. So you can create a Stedi API key in your Stedi account through the Stedi portal. I've already created a key here, so I won't show you how to create one. And what we're going to be using is a test API key. Test API keys are great for demos and integration tests for a few reasons. One, they use Stedi's actual API. So you can use the same API endpoints you'd use in production, but test API keys only work and respond for predefined mock requests. What that means for us is that there is no possibility of me leaking PHI. All of the data that's sent out and returned is 100% fake, and the test API key can't actually work with production data. Obviously, if you're in a production environment, you can use a production key and it'll work just fine. So you can just simply replace your test API key with a production key with no other code changes, and things will work fine. Obviously, you'd want to send in actual information for a real patient as well. So I've switched this over to the terminal, and I'm in the same repo as the reference implementation repo that I provided with you earlier. Next, what I'm going to do is use a SAM build command. What this command does is it essentially looks for the template that I showed you earlier, and then it builds the Lambda function locally. This should only take a few minutes. I said minutes, I actually meant seconds. So it looks like that's done. Next, what I'm going to do is provide a SAM deploy command. So we've already built the Lambda function. Now we need to deploy it to the AWS cloud. This command is in the README of the repo that I showed you earlier. You'll note that it uses a region that my AWS account is synced to, and then also my profile. You also notice that I use a clearly labeled test API key. As I mentioned before, in a production environment, you could use a production API key here. So let's run this command. And in my experience, these tend to take a little while. So what I may do is pause the recording and then cut ahead until when this is finished. We'll accept this change set. So I'm going to pause here and then I'll start it back up once it's done. Okay, great. It looks like the Lambda function is deployed to the AWS cloud. And what I'm going to do here is copy this ARN or ARN. This is essentially a unique universal address for our Lambda function. And later we're going to need this to wire up the function and create the integration with Amazon Connect Health. Okay, so we're back in the browser now. I'm going to walk you through the steps of connecting that Lambda, that integration that we had with Amazon Connect Health. So Amazon provides some really good instructions for this. I won't cover all of this, but what I'm going to do is cover the broad strokes of setting up the domain, which is essentially a top-level container that houses all the resources that your agents need for Amazon Connect Health. So moving back to the AWS console, we're just going to go to Amazon Connect Health. You could also type it into the search bar here. What we're going to do next is click Create Domain. I'm going to move my head over a little bit. And so if you remember earlier, the integration works with patient engagement agents. So you can either select agents for both or agents for patient engagement here. I'm just going to leave it set to agents for both. Then you're going to need to give a name to the space for our agents. I'm going to just do Stedi RTE, that stands for real-time eligibility, demo, ABC 123, XYZ. So that should be unique enough. I'm going to add a user here. I'm going to pause the recording because I'll need to put in an email address here. I'll show you what it looks like first. So here's the email address field. I'm going to pause real quick. Okay, you can see that that user was successfully added. And now we're going to need to enter that Lambda function ARN that we copied earlier. All right, so let's paste that in. And then we click Create. So great, it looks like our domain got set up pretty quickly. So what we can do next is open this application. So great. This is where you would come in and actually customize your agent, so your patient engagement agent, and set it up here. So you can see here that the integration was added. So in order to show you how a voice call would work, I would actually need an EHR connection. And right now only Epic EHR is supported. I don't have a license for Epic EHR, but what I will do is show you a really quick demo of the Lambda function. You'll get to see what type of data the voice agent would pass to that function, and then the response that would be sent back to the agent. So what I'm going to do here is switch back to our console home. I'm going to go to Lambda, and just like before, you could actually search for Lambda. So this is the Lambda function that we created earlier. I'm going to click in here. Then I'm going to go to test. And there's some event JSON here. This is essentially what information the agent would pass to the Lambda function. So I mentioned earlier, a patient would call, provide like their member ID and their name. This JSON is how that information would then get passed to our Lambda function. What I've done in the reference implementation that I set up is done a quick test event. This is based on that mock request that I mentioned earlier. So a lot of this data is fake and it's designed to work with the test API key I created earlier. So I'm just going to paste that in. We're going to go up and click test. The function is running. And now we can see the response. This 200 status code means that the request was successful. So it received the data from the AI agent. It made the API request to Stedi. Stedi returned a response, and then it returned this response that you're seeing here. And you can see what the Lambda function passes back to the AI agent. So this status active means that the patient has active insurance coverage. This period start and period end date tells you when the patient has active insurance coverage for. And then this patient information expected service cost is actually a copay amount. So one thing to note here is that the agent currently doesn't provide a way for you to send in or get back out benefits that are organized by service type code. Service type codes are broad categories like behavioral health or chiropractic. It's essentially how you tell a payer in a real-time eligibility check what type of benefits you want back. Because we're using a mock request here, I knew that this request returned information about chiropractic benefits. And so the Lambda function is hard-coded to find the STC in the response related to chiropractic benefits and return this copay amount. However, if you were using this for, let's say, a psychiatrist, you could change that service type code and it would retrieve the right copay amount for you there. Well, that's it. Thank you for watching.